So this is our second lesson in Chapter 15, Section 2. And in this lesson, we're going to continue with our introduction to radicals and learn how to simplify radicals. So the first thing that we're going to look at is called the product rule for radicals. And the product rule basically states that if you have the square root of a and the square root of b that are real numbers, then you can actually find the square root of a times b by separately taking the square root of a and the square root of b and multiplying those together. So basically, the root of a product is the product of their roots. The radicals basically can be broken apart or actually put back together if that was something that you would need to do. So in order to simplify some of these radicals that we're going to deal with here, we're going to make use of that principle. And we're going to start out similarly to what we did in the last section. We're going to break down the square root of 40 by finding the prime factors first of 40. So 40 is, of course, an even number. And we can divide that by 2. And 2 goes into 40 20 times. My pen isn't cooperating here. And then, of course, 20 is also even, which we can divide by 2 again, and we get 10, which is still even, so we can divide by 2 another time, and now we get 5. So the prime factors of 40 are 2 times 2 times 2 times 5. And as we saw in our last lesson, since this is a square root, that means things come out in pairs. So I can bring out that first pair of 2's, and that becomes 1, 2. But I can't take out the 2 and the 5 that are remaining because they don't have partners. So I'm going to have to leave them in the radical, and of course 2 times 5 is 10. And we're going to do something similar with the square root of 300. We're going to begin with 300. And we know that that's even, so we'll divide that by 2. And that gives us 150. And of course, you can use your calculator to help you with this. And then we're going to divide that by 2 again because that's still even. And 2 into 150 goes 75 times. Now 75 isn't even, but it can be divided by 3. And 3 times 25 I think I'm going to have to get a new pen. Is 75, and 25, of course, can be divided by 5, and 5 goes into 25 5 times. So the square root of 300 is 2 times 2 times 3 times 5 times 5. And as we saw before, we can bring out the 2. We can also bring out the 5. And when they get outside, they're still multiplying because they were multiplying underneath. What we can't do anything about is the 3, so we have to leave it under the radical. And then, of course, 2 times 5 is equal to 10 times the square root of 3. Now, our last one, we have the square root of 15. And 15 isn't even, but it can be divided by 3. And when we divide it by 3, its other factor is 5, and we only have one 3 and one 5, so this is in simplest form. So there's nothing we can do to simplify that one. It's already in simplest form. Now, if we're trying to simplify 7 times the square root of 75, then what we need to do is take that 75 and break it down into its prime factors, which is 3 times 5 times 5. And because 5 times 5 is a perfect pair, we're going to bring that 5 outside and multiply it times the 7. So 7 times the square root of 75 becomes 35. 7 times 5 is 35 times the square root of 3. We also have something called the quotient rule, and my slide is not correctly identified. Let me skip ahead and see if it's correct on the next. Let me come back and actually make that a quotient. So we'll just scratch that out. What we're trying to find is the square root of A over B. And if A and B are real numbers, as long as B is not equal to 0, that's very important because remember we cannot divide by 0. As long as B is not equal to 0 and the square root of A and the square root of B are real numbers, then we can simplify the square root of A over the square root of B by taking the radical alone with A and divide by that same radical alone with B, just like we did with multiplication. So we're going to do an example one. Nope. And our first example here says to simplify the square root of 5 over 16. So our first step will be to break the radical apart and put it over the 5 and put it over the 16. And the square root of 5 is not going to simplify any further. It's going to sit there just like that. But the square root of 16 is the square root of 4 times 4. So what we actually wind up with is the square root of 5 over 4. And similarly, Square root of 40 over 81 is the square root of 40 over the square root of 81. And since 40 is 4 times 10, and 81 is 9 times 9, then the square root of 81 is 9. And since we can take the square root of 4 and get 2, in the numerator we'll have 2 on the square root of 10. I did take a couple of little shortcuts there in this last problem, so if you don't understand, you might want to go back and break down 40 into its prime factors, remembering that 40 is equal to 2 times 20, which is equal to 2 times 10, which is equal to 2 times 5, which is equal to all the factors. And for that reason, then, the pair of 2's came out. That's the 4. And then the 2 times 5 had to stay in. That's the 10. So again, we're going to try to simplify the radical expressions. And we're assuming that variables represent positive numbers. So our first example is to take the square root of x to the 7th. So like we had before, we're going to break that up into the square root. And I'm just going to write the index just as a reminder that things come out in pairs. And x to the 7th is 1, 2, 3, 4, 5, 6, 7. And those are going to come out in pairs until we run out of pairs. So we've got 1, 2, 3 pairs of x's, which when they come out will become x times x, or x cubed. But the remaining x is going to stay underneath the radical. Our example B is to take the square root of 20, and 20, remember, is 2 times 10, which is 2 times 5. Over the square root of x to the 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So bringing things out in pairs, the 2 will come out, the 5 will stay under the radical, and then we'll have 1, 2, 3, 4, 5, 6, 7, 8 pairs of x's, which will give us x to the 8th power. And again, just remember that the index is 2 and 2 goes into 10, or excuse me, 2 goes into 16 8 times. So that's the shortcut for that one. So we're going to practice now with cube roots. And the cube root of 16 16 is 2 times 8, which is 2 times 4, which is 2 times 2. And bringing those out in groups of 3 means that one set of 2's comes out, and the remaining 2 stays under the radical. And be sure that you do put your index, because this is not a square root, it is a cube root. And similarly, we have the cube root of 3, which does not break down, over the cube root of 64, which is 2 times 32, and 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So we wind up with the cube root of 3, and then counting our 2's, we have two sets of 2's that are in 3's, so that'll be 2 squared, or 4. So this concludes our lesson on simplifying radicals. And again, you should do some homework, make sure that you understand how to do these, and ask questions on any problems that you don't understand how to do.